Welcome, this is another Khan Academy support video. Specifically, we're going to be taking a look at the second assignment that I'm highlighting right now, the one called Slope-Intercept Equations from a Graph. This assignment is the converse or the reverse of your first assignment. Here they're going to now give you a linear equation that's already been graphed out, shown on the graph, and your job is to figure out what was the equation that would create this graph or that could match the blue line that we see. I'm pulling up some notes on my screen right now. They are the similar notes from the first assignment about Slope-Intercept Form. Specifically here, you should recall that every linear equation can be written in Slope-Intercept Form if you know two things about the linear equation. We call it Slope-Intercept Form because once you know the slope, what I've shown here in red, and once you know the y-intercept, what I've shown here in green, then you can easily or quickly write a linear equation to match that graph. B, of course, stands for the beginning point for our linear relationship. It is the y-intercept. It says, where does the line begin or start out on when the x value is 0? That point, the y-intercept, will always be located on the y-axis, because if we make our x value 0, then the y value is somewhere on this y-axis. So here we see for this y-intercept, I'm going to go ahead and mark in green this point right here. It's weird. Okay, and this point in green right now that you can see there is located at 0 and -3. So if it's located at 0 and -3 for that point right here, then that 0 and -3, this data point, this y-intercept here, is really going to be my y-intercept. So based on right here, this point here tells me a y-intercept of -3, so I'm going to go ahead and plug in a -3 for the y-intercept. That says y starts out at -3, and the x is then going to change it or cause this blue line to move up. That's what m stands for, the slope, the rate of change. So in red here, I'm now going to go ahead and find two data points on this graph that we could use. And I'm going to use the y-intercept as one of them. And I follow this blue line, and I'm looking for other corners of grid boxes. I could go right here. That'd be fine. But I'm just going to choose this nice clean point that's right on the 6 on the x-axis. Again, to measure slope or rate of change, you can pick any two data points from the blue line. Please pick points that are on corners of grid boxes so that your life is easier and you don't have to use decimals as you measure slope. Here, slope is going to measure the rise over run to get from one data point to the next. How much do we rise? How much do we move up? And so we move up here by 3 units, and then we also have to move right. So to get from this first data point to the second one, we climb up, we rise by a total of +3. And we also run sideways by a total of +6. So here you see we climb up by 3, so that's our rise of 3. We climb over by 6. So our slope, our rise over run, is going to be this +3 for the rise, this +6 for the run. I'm going to put those down here. And if this is a fraction, 3/6, I want to simplify that fraction as far as I can. And the fraction 3/6 is the same thing as 1/2. So we're going to go ahead and simplify this to the fraction 1/2. So here we see again, quick recap, I found the y-intercept of -3 right here. That's where the line crosses with the y-axis. And then in red, by using two data points, I was able to measure a slope of 3/6, which can simplify to just say 1/2. So I'm going to plug that slope of 1/2 in. And again, we found up by 1, right by 2 is our slope, and starts out at -3. That's where the y-intercept came from. Okay, so now we have a new graph here. Same situation, they've graphed out a blue line for us, and they ask us to go and find the equation that would match this blue line. The first thing I'm going to do is I'm going to go ahead and identify my y-intercept. And I see this data point, I see the blue line crossing with the y-axis right here. So that tells me that my y-intercept in this case is going to be 0 and -9. We have a y-intercept here of 0 and -9. So if that's my y-intercept, I'm going to go ahead and plug in a -9 to represent the y-intercept as negative here, or y starts out with a value of -9 when x is 0 at the beginning. Now after it starts at -9, we see this blue line starts to gain. That's going to represent the movement, or our slope. And to get slope, I can pick out any two data points. I would encourage you can use the y-intercepts. I see a data point right here. That's on the corner of this grid box, lines right up with 1 for x and -5 for y. I'm going to go find another data point right here. Again, you could use the y-intercepts, but I'm just going to use two different data points. This one and that one. Now I want to measure the movement, the rate of change for this line from the first red data point to the second one. So I want to break this down into how much does it move vertically, that's going to be the rise, and how much does it move side to side horizontally, that's what we mean by run. And here I started out at -5 on the y, and I climbed all the way up to +3. So if I jump by 5 and 3 more, that's a total of +8 for my rise. So I've gone up by 8 units on the y-axis, and then it also travels to the right from 1 over to 3, or by just 2 grid boxes. So I see that that's going to be a +2 for my run. This line has movement of rising by 8 and run by 2, so that means my slope is going to be 8 over 2. And then the question is, could we simplify that slope 8 over 2? And yes, 8 divided by 2 simplifies. That can equal a slope of 4 over 1, because 8 divided by 2 simplifies to 4 over 1, and Khan Academy wants you to simplify even further. If I try to put in 4 over 1 here, you'll see that they say your answer is almost correct, but it needs to be simplified. They want you to simplify as far as possible, so they really want you to simplify that slope of 4 over 1 all the way to just a whole number, a slope of 4. So we get y equals 4x plus -9, y-intercept of -9, and then the graph climbs up by 4 and right by 1 repeatedly. We're going to show one more example and then wrap this video up. For this last example here, let me get the work from our old problem out of the way. For our last example here, we see, again, we need to come up with an equation that's going to match this blue line here. I'm going to first identify my y-intercept. I see for this graph it has a y-intercept, or it crosses the y-axis right here at that -2. So I'm going to go ahead and call the y-intercept -2. This graph starts out with the coordinates 0 and -2. In other words, the y-intercept is -2. I also need to measure my slope, and I'm going to measure slope by picking out two data points. I'm going to go ahead and pick this data point right here. Put that in red. And then I'm also going to find one more data point. I keep following this blue line. I see it hits right there on this corner. So with 8 and 4 is another good data point. And again, we're going to measure rise over run, so quickly we'll measure how much does it travel up compared to how much does it have to move sideways. That's rise over run. It starts out at the 1 and it climbs up to 4, so that tells me that it moved up vertically by 3 units. It did a +3, 1, 2, 3, and then it ran from 4 to the 8, and to get from 4 to 8, that must be a gap of +4. Or the run was +4 because it moved 4 to the right. 1, 2, 3, 4. So that gives me a slope of 3 over 4. My rise is 3. My run is 4. So I'm going to go ahead and plug that 3 over 4. There's no way to simplify that fraction any further. 3 over 4 is going to be our slope. I hope that was helpful. Again, the key to come up with equations to match linear graphs, or at least to come up with slope-intercept equations to match graphs, you find the y-intercept, plug that in for b, then you measure the slope by using 2 points on the line, measuring rise over run, and that becomes the m, or the slope that you plug in. Hope that was helpful. Thanks for watching to the end. Feel free to send me an email if you need additional support.